Santa, Santa, Santa.
Ho, ho, ho!
Hi, my name is Chris Broadfoot. I work on the Google Maps developer relations team based in Sydney, and in my 20% time, I was the technical lead for Santa Tracker.
Hi, I'm Ankur Kotwal, and I'm on the Android developer relations team. In my 20% time last year, I did Santa Tracker as well. I was the mobile technical lead. So thank you for joining us today. We have what will be hopefully a fun talk for you. We're going to give you an overview of what Santa Tracker is as a project. Then we're going to talk about how we built it. And then we'll talk about some interesting technical considerations that we found along the way. But really, the key takeaway here is that Santa Tracker was built on Google's developer platform, using technology that you can use today and build similar solutions yourself. So let's go back to the very beginning. In 2004, 10 years ago, Google acquired a small company called Keyhole, who had a product also called Keyhole. Keyhole actually became Google Earth. But in 2004, one of the engineers on the product, Brian, decided to put up a route of Santa traveling the world. He did this as just a small little project on the side, and he published it on the Keyhole BBS. He had the backend running on a single server and thought a few people from this BBS may download it. He actually had 25,000 unique visitors that night, and we were just blown away. It was great. And we've continued that Google Santa Tracker tradition now for 10 years. So let's see what it looked like in 2013. Click.
So we built a brand new village with a countdown. We had some great animated videos. We had games, interactive HTML5 games. And of course, you could track Santa across Google Maps.
We also had an Android app where you could follow Santa. And we integrated with Chromecast, so you could see him on the big screen.
So we provided interesting statistics. You could track Santa across Google Earth and across the whole web using a Chrome extension. So we had great HTML5 games that worked well on mobile. And we sprinkled Santa across all Google products. So Google Maps, on Google Maps on desktop as well.
That was Santa Tracker 2013.
So I'd like to give you a little bit of an overview just on the website. We rebuilt this the ground up to showcase the best of Google's developer platform. So as you can see, our village has a countdown where you can see the time Santa's going to take off. And these houses that unlocked throughout the month of December are kind of like an advent calendar. So we have these scenes that just are CSS animations, games, and Easter eggs. So when you click the balloon, it just takes off. It's got some audio effects as well. This is one of my favorite games. It's a physics game called Gumball. And you just rotate the field of play, and you drop these balls into the hopper.
We were able to bring this to Android as well.
Yeah, so this one was really fun, and I think this was our top used game, actually. So we had this menu that demonstrated the advent calendar, and these things actually unlocked throughout the month of December. So you can see the great CSS animations. We really pushed the limits of the web. So we even created a WebGL HTML5 game. This was based on Instrument's Chrome experiment, and Santa dives into your favorite city. So there's these really silly audio effects that are kind of charming, and he just dives through the candy canes onto a Google map. So yeah, everything's WebGL, all of the clouds are WebGL, and the Google map underneath is transformed using CSS transformations. It's really cool. So yeah, we also sprinkled Santa throughout Google products. This is what it looked like on Google Maps. It just prompted people to go into the website, and the Street View Pegman donned a Santa hat as well. So we introduced him into our mobile applications as well. Just a card on our Maps application, and you could actually track him in the Google Earth application using a KML tour.
So Santa Tracker actually covers a lot of Google technology. As I said, it's built on the Google Developer Platform. And it's a great way for us in developer relations to prove our technology as well, because it has a seamless experience from mobile to web and through the backend. And so we'd like to show you what that is right now.
Right, so as Ankur said, anyone can build this. We're using our developer platform. So we had two main experiences. We had the web application and the Android native application. Both of them made heavy use of Google Maps API, one of my favorite APIs. And were both powered by a Go runtime AppEngine application, which we called the Santa Tracker API. Now, this is just our internal API, but if you do want to build your own Santa Tracker and use this, please do get in touch with me. We'd love to have everyone tracking Santa using this. So it provided two main pieces of functionality. Synchronizing time, so if people's computers didn't have the right time, then everyone would be tracking Santa at the right time, and also a feed of his previous and next destinations. So all of our clients would periodically re-request this information so that they get Santa's latest location. So each destination also provided a bunch of metadata, such as when Santa arrived there, when he departed, the population, and the number of presents he delivered up until that point. So not the number of presents he delivered at that stop, but all the way up until then. A localized city and region name, which we showed in the tracker, and the location.
Yep, it worked.
Yeah, so this API let us reach many, many people around the world, providing internationalization into 34 languages. You can see our diverse audience here. So we had people from all sorts of different locations and languages. And you can see the US accounts for about 32% of our audience. When reaching a wide audience, it was also really important that we support a variety of screen sizes. So this is a mock that we got from our designers showing how we'd get the advent calendar to fit to a small screen. You can see the, well, actually, first you can see the locking as we go through the month. But you'll see some of the UI elements disappear as the screen gets smaller. The back button for the Go to Village collapses into a separate row, and the icons go from 4x6 to 6x4. So I'm just going to show you a couple videos showing you how this works. So this is our village. There's a few breakpoints. You can see the countdown gets smaller. We hide a bit of text, just so that we can show those graphics, because we feel they're more important than that little bit of text. Some of the buttons disappear and rearrange to fit the smaller screen as well. So on the advent calendar, everything sort of gets smaller. The icons have a few breakpoints to get smaller as well, and you'll see the Go to Village button collapse into a separate row. And of course, the dashboard, which is quite complex and shows a whole bunch of different statistics for Santa. The text gets smaller as the screen size gets smaller, and all of those statistics go from 3x2 into a list. So when building the site, performance was really important. We wanted to make sure people were engaged, that the site loads quickly, the games are responsive, and the Chrome developer tools, particularly the timeline view, is really important for that. When we added snow, we saw an immediate drop in frame rate, probably from about 50 frames per second down to 10 or 15. And we used the Chrome developer tools to figure out exactly what Chrome was doing. So it turned out whenever a piece of snow fell to the bottom of the page, it was triggering a whole page relayout, which is quite expensive. And we had a lot of snow. So the Chrome developer tools were really useful there. They're also really good for testing your responsive layout, right? You can emulate mobile devices. And the Web Fundamentals website is a really good resource for both performance and multi-device layouts. To keep the site responsive, we used a module system. So each of those experiences we crafted into a separate module so that the site loaded really quickly upon first load. When the user goes into a game, they load that module, which preloads all of its assets, such as images and audio, and shows a loading bar like this to the user, just to keep them informed and engaged. We made really heavy use of Google Analytics as well, not just to figure out where people were engaged and where we could make improvements, but also to track all of the errors that happened on the page. So by adding a global error listener, we were able to send those errors over to Google Analytics to figure out any problems that we were having in production. We actually found a bug that was only manifesting in IE10 in Japanese, which was really strange. It went straight to the top, and we were able to fix it. This is something that we never would have found during manual testing.
So let's talk about the Android app. So you'll see here, this is what our village looked like. And just like the web, this was a 12,000 pixel wide image that we're rendering. In fact, it's not a single image. There's multiple layers of images here. We use a technique called parallax scrolling, where the clouds are actually scrolling at a slower rate than the foreground, than the village itself. And in order to accomplish this sort of rich detail, we actually built a set of our code was written using the Canvas API on Android. We found, though, with the Android app, we didn't have an advent calendar event for every single day. So instead of having advent items on the actual village itself, we started using these bigger marker pins. We actually prototyped using the navigation drawer here as well. And we found that the navigation drawer, which is a fairly standard and common pattern on Android, didn't really fit well with the Santa Tracker experience. The navigation drawer is really there for primary navigation, and you typically need more items in that navigation drawer in order to fill it up. Otherwise, it just looks empty. Also, because we were building what looked like a fairly custom experience, almost like a game, it made more sense to build a very rich and visual navigation menu rather than just using the drawer. But really, the question that we asked ourselves time and time again is, why do we want to build a native app? And it was really down to performance. We wanted to build this rich experience and have it perform very well on for our mobile users. We also built these games that you see on the left-hand side. And so we were able to take advantage of the accelerometer on the Tilt game, as well as on the Jetpack game. It's actually kind of an action game where and we'll see a video in a minute, but the elf flies around the screen and you have to collect presents. So it was really important that that game and those sorts of experiences stay responsive. And we could only really get that level of responsiveness, again, through a native app. The other advantage of being a native app is that we implemented notifications. In fact, just one notification, and that notification went off when Santa took off on Christmas Eve. And it was really fun because suddenly we started to see all of these people posting on Google Plus and Twitter that, hey, my phone just told me Santa's taken off, and they would tap that notification and jump straight into that map experience. But it was one bit of feedback that we had from our early testing was make that notification silent and make sure it doesn't vibrate the phone or tablet. Because when Santa takes off, around half the world is asleep. So they didn't want to get woken up at 3 a.m. just because Santa's flying around the world. One of my favorite parts of the app was the ability to use the Google Maps API for Android. And you know, the best thing for me for this API is the use of the camera. And so it's not just a 2D camera, it's actually a 3D camera. So you'll see as Santa arrives here at Sydney, the camera zooms in but also tilts ever so slightly to give a really good sort of perspective. And as you zoomed in on various cities around the world, where we had support for it, 3D buildings show up as well, and they just start popping up on the map. It just gives a really immersive experience. Another part of that, of adding immersiveness to our map here, was the way that we wanted the camera to follow Santa. We really wanted it to feel like there was someone holding a camera from way up high, kind of keeping track of Santa as he traveled. And in order to do so, we made sure that Santa wasn't always at the center of the screen. So you'll often see that the camera rotates and spins around, And sometimes it actually gets ahead of Santa and waits for Santa to catch up, and sometimes it falls behind and then it catches up. So we were able to put these sorts of effects in to just make that experience that much more immersive. We called this Santa Cam. Yes, I know, very original. On Android, we wanted this app to be available everywhere. So again, like a web experience where we were typically targeting Chrome, gingerbread devices would have been excluded from using Chrome for Android. We wanted to make sure that this app was available to all of those users, and we wanted to make sure it was available across screen sizes and form factors. So we built a responsive layout on our apps as well. Now, if you look at the middle screenshot and the screenshot to the very right, you'll see that we've got a difference between portrait layouts and landscape layouts. We've vertically stacked the portrait layout, whereas on landscape, we've got the two views side by side. But we were also able to put in this little summary mode that you can see on the phone on the left, where you can get rid of the dashboard and see more of the map and see Santa travel around the world, and just have a little summary at the bottom. And that summary was like a carousel, where we still wanted to show those various statistics from the dashboard, but we just swiped them along one by one. We'd show how many presents were delivered, or what his previous destination was, or how long he had been in flight. Games. This was really fun building and testing. So this game you see here is the Jetpack game written by an engineer on our team, Bruno. And it was actually built using a custom OpenGL engine that he wrote in Java. And yeah, this one was one that we certainly played a lot when we were testing the game. For the other two games, if you look at the tilt game at the bottom left, and you can't really see the tilting here, but in order to control it, it uses the accelerometer, as well as the memory match game on the right-hand side, they just used the standard Android view hierarchy, because we were able to, again, build a very custom look and feel, make it feel like a true game, without having to go to the extent of building a whole engine for it. Again, using the right tools for the job for the type of job you have was paramount. We wanted the Jetpack Racer game to be fast and fluid whilst being responsive. And in fact, when Bruno tested it on a Nexus 1, he got something like 45 frames per second with something like 25 presents on screen at a time. And so you can imagine on a device that old, when it performed that well, from that point forward, everything was just fast and fluid from there. But playing games is great. But what I like to do is I like to play games with others. And these games were still single-player games. So we started integrating play game services into Santa Tracker. What Play Game Services allows you to do is sign in with your Google Plus account and then participate in the leaderboards and earn achievements. So from our point of view, it was a way of driving engagement in the app, but it took off in a way that we hadn't really anticipated. For starters, people that use the Santa Tracker app are much better gamers than our team. In the first 15 minutes or so of the app being live, our best scores had been eclipsed. The important thing about the integration with the Play Game Services here was how we suggested users sign in. So what you see with a lot of games these days is that as soon as you launch it, it prompts you to say sign in with your credentials. We didn't want to be so aggressive about it. What we did instead is that we waited for the user to play the game, and then on the high score screen, at the bottom you'll see we asked them, would you like to sign in to unlock achievements and participate in leaderboards? And our sign-in rate was actually very, very high. People really loved being a part of this. So in the months leading up to Santa Tracker's launch, Google announced a new product, Chromecast. And immediately, we were fans of it. We wanted to see Santa on the big screen. So Google Santa Tracker was actually one of the early apps to integrate with Chromecast. Integrating with Chromecast, however, brought new challenges. One, it was a big, huge screen, and it was meant to be a lean-back experience. So that meant we needed to take all of the controls away from the user. So you might have controls on your website or on your phone to zoom and move Santa around, but we wanted to take that away. Your phone or your tablet effectively acts like a remote. So you would drive it from the phone, but you wouldn't necessarily have any interactive controls on screen. Chromecast, by the way, is the intention of Chromecast is that you don't mirror what you're seeing on your phone or tablet. What you do is you launch an experience on there that's tailored for that screen. In fact, Chromecast, which is the physical size of a Chromecast, is about the size of a USB flash drive. It's actually a low-powered device, but it runs the Chrome browser. So when you cast to the TV, it actually ran the website. And some of those performance tools that Chris mentioned earlier really became important because it's a low-powered device. So some of the differences that you might have seen are lower snow densities or fewer concurrent audio streams. So we definitely tailored the experience for it. So on December 24th, Santa takes off regardless of whether we're ready. So it's a really interesting engineering project because we can't slip up. So it's really important to us that we make sure we deliver a fantastic experience on that day because there is no way for us to really revise it from that point forwards. So let me show you some of the techniques that we use. This is what the desk of a typical Android Google Santa Tracker engineer looks like. Most of our colleagues walk past our desk and don't believe that we're working. But this is the way we kind of test Santa in flight. And you'll see here that we don't have 3,000 Android devices because it doesn't actually require that many to test this kind of experience. You have a mix of form factors. So we have some tablets, we have some phones, and we have a mix of screen sizes. And within these devices as well, we have a mix of operating system versions, different versions of Android. And basically, we were able to represent the majority of Android devices just with a fairly small collection. Leading up to it, however, we also need to do full simulations of Santa in flight. We call those dry runs. And this is where the whole Santa Tracker team, regardless of whether you're working on the mobile app or you're working on the web or the back end, we all get together and we simulate Santa journeying across the world. Now, in that simulation, we have to assume where Santa's going to land. Because on the day, I mean, we find out just-in-time updates from Santa in terms of its position, right? So we make something up for the simulation. And we go through the whole day. And all of us, we have phones and tablets and laptops and desktops sort of simulating Santa. We want to make sure that if you turned it on at the beginning of his journey, 25 hours later when he finishes, you're able to run that through and we don't run into any performance problems or stability problems. This photo here is actually of the Google Sydney reception. One of our engineers, Jan Felix, got a little bit carried away with the dry run and took his Nexus 10 and hooked it up to our big screen in reception. And we basically took it over for the day. So on that 15th of December, when we had visitors in that office, they were very confused as to why Santa was flying across their screens.
Yeah, so as Ankur said, we need to make sure that all of the applications work functionally. We also need to make sure that they can take all of the load. We see over 100,000 concurrent users on the website at some points in time. And at other points in time, over 50% of those were from mobile. This is what the traffic shape looks like. When I first joined the team, I was told that we just get a barrage of users. But that's actually not quite true. As you can see, it's kind of a gradual growth, which plateaus, and then they all fall off as Santa touches down in the North Pole. So to make sure the backends work, all of our apps work, we run load tests. You can see the AppEngine dashboard while we're running one of our load tests. So we actually took this one up to 10,000 queries per second. And by taking it up that far, we were pretty confident that we were going to be able to support the main event. You can see the average of our instances was 250 queries per second, but we saw some of them fire up to 800 QPS, which was very good. And I think this is largely due to the Go runtime on AppEngine, which is really, really high performance. You can see the memory consumption is quite low as well, which is really good. This is what a graph from one of Google's back-end servers looks like. So I think this is from our Google Maps tile server. You can see on either side of Christmas Day, the traffic is relatively smooth. But during Christmas Day, while Santa's running, the traffic gets really, really spiky. You'll also notice that the volume of traffic isn't that much higher either. This is because the whole of Google experiences a little bit of a dip. So Santa Tracker kind of fills that gap, which is really good, just keeping our backends in shape. So the spiky nature of the traffic is primarily because everyone is looking at the exact same thing at the exact same time. So everyone is hitting the same kind of requests. And the larger spikes, I think, are because when Santa's traveling quicker, say, for example, over the ocean or just quickly across a continent or something like that, then people are requesting many, many more tiles. So we try to smooth that spiky traffic using a technique called Jitter. So the top half of this slide shows our internal flags, which we can change during the event. And that lets us delay people randomly, and we start with 2 minutes. So we try to smooth people out over a 2-minute period. So if you opened your phone and your desktop machine, you may not actually see Santa in exactly the same position, but they'll be pretty close. We can also control how often our clients re-request these flags. And we jitter those as well, of course, just to make sure that the traffic to our API server is also quite smooth. So yeah, these flags are stored in the AppEngine data store, and they're cached using memcache and also with a local instance cache. It doesn't really matter if these flags are a bit stale, so we can just cache them in memory. And those flags come down to the client when they're re-requesting these flags periodically as well. So you'll see the time offset field there, and that should be the same value throughout that user's experience. So once you're delayed that amount. We also use this endpoint to safeguard against unexpected events. We haven't actually had to use these flags, but we're able to turn off entire experiences. For example, we could shut down the tracker map on the Android application, or switch off the entire website using these flags. We can also disable particular features, like the tracker or Google Earth, or if there was some problem with our photos, we could just turn off the photos as well. We just kind of added these. It was really lightweight to add these in our code base, so we just had a whole bunch. We can also make Santa fly higher or lower using Google Earth, and that directly affects the number of requests that are being sent to our Google Earth backends.
So we use these flags even in the mobile apps. So for those of you that tried to unlock the games early, this is why you couldn't get through. But with that, we just want to we want to first thank our Santa Tracker team, but we also want to thank you for joining us. We have collected a whole bunch of references. You would have seen reference documents throughout the presentation, things like web fundamentals or the Android design guidelines. We've collected them on one page for you at this short URL. And from there, you can also provide feedback for this session. So thank you for joining us. And we have time for questions. So if you would like to come up to the mics and ask any, here's your opportunity. Thank you.
Thanks.
Here we go. That's right. Don't be shy.
I've got questions.
Oh, you've got questions?
So do you guys have kids, and do they ask you to ask Santa things because they know that you work on this?
So two-part question, so I'll answer the first part. Yes, and my kid basically throughout this project found that he would see more of Santa as the project got deeper and deeper. So he learned to recognize all of our visual assets, but he actually learned to recognize even the music. So even if I was testing like late at night in a room on the other end of the house, he would run around going, "Santa, I can hear Santa."
It's quite traumatic.
For me too.
Thank you.
Okay. So this is a very interesting project. I'm wondering how many engineers actually involved and how much effort they spend.
It varies. Like we have, so Ankur and I and a couple others, like kind of core team, we spend a lot of time over December. We've got people that are 20%, sort of like 10%, especially those that are integrating it into the products they work on every day, like Google Maps. So yeah, there's quite a varied number of people. Yeah.
So
it would be in the tens, I would say.
Yeah.
Around 10?
No, in the tens, but like 10 to like 30 or so.
Yeah. So I mean, so if you saw one of the screenshots that we had on Google Maps, we had Pegman having a Santa hat. Like that'll be one of the engineers that works in that team, so there's not a lot of effort for them to just change Pegman for that duration, which is why Chris is like, the effort varies, but the core Santa Tracker team is about 10 plus people, but there's more people that get involved on those sort of periphery.
Yeah.
Okay, thank you.
So I realize Santa is on vacation right now. So, is there any way to find him, like get him back, just to show my friends like what this whole thing looked like?
You can send them the YouTube link for this presentation.
Okay.
Yeah, there isn't, unfortunately.
Yeah, unfortunately not.
Yeah.
But he'll be back again in December if they can wait that long.
Yeah.
Right.
Did you guys have any time to run usability testing? Because this is like a secret. It cannot be seen before Christmas in a way.
Yeah, we don't, and that would be really good. Like once we started adding, well, it would be nice to. Once we started adding a lot more things to the village, it got quite difficult to let people navigate around, which is why we added that 6x4 menu, because the village is really, really long. You've got to scroll around, and that's kind of the fun of it as well. You kind of explore the village as well, and enter experiences.
I might just clarify on that. We for things like Android and Google Cast or Chromecast, we certainly have design guidelines and UX guidelines. So we have to definitely be compliant with those. And we have a team internally that also reviews our own apps and make sure that they meet that criteria. So we do rely on the same documentation that's available to developers everywhere to make sure that we're doing the right thing as well.
Thanks for that. It's a really interesting project. I was just wondering whether there was any stats available on how long it took Santa to kind of deliver each present or to go between different locations.
Oh.
His whole journey is like 25 hours.
He flies it. Well, we don't really know how he flies as well. I think it's beyond the speed of light, I think. Yeah. I don't know, we calculated.
So probably a fair guess.
Yeah, there's some strange physics going on there.
Yeah, those reindeers are pretty quick.
Yeah.
Thanks.
Okay, well, we'll be around, so thank you very much for your time.